Okay. Excuse me. Okay, we're building upon what it is that we did last week. Really, the only thing that's happening now is we have two linear equations. Everything's exactly the same thing, but a solution is where two lines in the direction of the inequality is shaded in both areas. So, a solution would be within here, not within here, not within here, not within here, where they both overlap. That's what the difference is within the section, and I'll go through it in detail. Pretty much the rest of the steps are the same. First, let me start with, you guys have a sub today. Please be on point. We have 2 days that we're working on this, and then we're testing on it. So those of you that worked hard last week, this test, a little bit more work because we have two things that we're trying to graph out, but at the end of the day, no real new concept except we're looking for shaded areas that both of them are overlapping. So, with that said, I'm leaving the stamp on the ledge. Please make sure that you get your planners filled out. You want to make sure that you sign in, follow rules, please. Make sure headphones, cell phones are put away, headphones are put away, and also show respect for the classroom. Make sure that the books go underneath the desk, your binders go back appropriately, and so on. That's something that's fairly important to me, but it's more important for class to class that you guys show respect, which you guys are pretty good. So, okay, so let's get started. First, vocab 421. In your handouts, you'll see you have a picture of the books. You don't even necessarily need to open up the book. Provided for you. System of linear inequalities, solution of system of linear inequalities. You want to write out what those mean. Okay, so, example A, we have an ordered pair of 2 and 1. We have two things in linear format, okay? We don't need to make any changes there. Step 1, we're going to write these side by side. So write both the equations, then we're going to substitute for our x 2 and our y 1, and go ahead and solve. So my y is 1, my x is 2. Remember there's a minus here, so I'm going to put parentheses in here, and then I'm going to solve for it. So, parentheses are going to come out, negative 2, because it's negative times the positive, turns it negative, negative 2 plus 4, 2. Bring down the 1, say this to yourself, 1 is less than 2. Yes, that's accurate. Go to the next one, y becomes 1, x becomes 2, 2 plus 1 is 3, 1 is less than or equal to 3. Is that a true statement? Yes, 1 is less than 3. So, step 4, we'll get to this in a minute after we do the graph, but essentially what we need to do now is we're going to take these two linear equations and we're going to graph them out. So we're going to start at 4, and we're going to go down 1 over 1. That's going to form our line. This one is going to be dashed. It's less than, shaded down. You should know this at this point. If not, hopefully you got it now. Y is less than or equal to x plus 1. So we're going to go to 1 on the graph. We're going to go up 1 and over 1. That is going to be our line. It's going to be solid. It is also less than heading down. So remember, less than heading down, going downwards, greater than heading upwards. Okay, so what does this mean? This means within this section right here where these two overlap, so it's going this way and it's going this way, where it overlaps, anything in here is a solution. So we go and graph the ordered pair out of 2 and 1, going to x2, y1, plot our ordered pair. It is within the purple shaded area, the orange shaded area, both linear equations. This is true. So 2, 1 is a system of solution. It's in both shaded areas. That's essentially it at the end of the day. We got some nuances that happen, which I'll cover, but notice it's very similar. Really the only thing that's addition or that's new is now that we have two lines, two linear equations, and we're looking for overlapping in regards to solution. Where last week it was whatever the shaded area was. Okay, this next one. So we have 8x plus 4y is less than or equal to 12. y is greater than 1/2 x minus 2. Both of these are linear, however this one is not in slope form. So the first thing we got to do is get this in slope form. So I rewrite the problem and I get y by itself. I subtract inverse operation minus 8x on both sides. Cannot combine these, they're not like each other. Okay, so this cancels out. We bring down the 4y, bring down the negative 8 plus 12. From here we're going to get the y by itself. We're going to divide both sides by 4. Gets the y by itself. Negative 8 by 4, negative 2. 12 divided by 4, positive 3. So now this is linear. So we have this line. We have this line. We're going to go ahead and write them side by side. And then we do not have an ordered pair for this one. So we're gonna plug in 0, 0. Or as we graph this out, I'll show you what we're gonna do here. So I'm gonna use 0, 0 after I graph them out, because once I graph this out, I go to 3, positive 3, and then I'm going down 2 over 1. Remember, inequalities, we never go to the right. So plus 3 down 2 over 1. There's my first line. It's a solid line. It's less than, shaded down. Next one, negative 2, or excuse me, 3, down 2 over 1. And then this one, negative 2, up 1 over 2. This is greater than, shaded up. Also, this line is dashed. This line is solid. Okay, so we want to pick a solution that's readily available within those shaded areas. So from here I can use 0, 0. And 0, 0 is easy because there's very little math going involved here. So I write both equations side by side. I replace the y and the x for 0 and solve. So half minus 0 doesn't matter. Cannot get rid of this negative 2. So bring down this negative 2 and 0. Same thing here. I have negative 2, 0. Doesn't matter because it's times 0. Bring down the 3, bring down the 0. Ask yourself, is 0 greater than negative 2? Yes. Would you rather owe $2 or owe nothing? It would be better to owe nothing. 0 less than or equal to 3? Well, yes. 0 is less than 3. 3 is on the right side of the number line. So 0, 0 in this case, both within the shaded area, works as a solution. It is, 0, 0 is a system of solution in doing this problem. Okay. Next one, we have 2 linear equations. However, this one's a little different because it's actually being taken from the graph, but I can't necessarily write that out. But looking at this, we can look at this graph and write this out. So this is very similar to the last 3 questions that were on your worksheet. By the way, you will have something on the test just like this with no linear equations whatsoever. You're going to need to write them. So, starting point, Adrian, is what? Where do we always start from when we go to graph? Adrian? Yes, that's correct. We start from the B, which is the y-intercept. So in this case, it's going to be 2. So I know that my y is 2. Then, Anna says now it's rise and run. So rise and run up to over 2. So in this case, 1 and 1, right? Because up 2 and over 2 is the same thing as going up 1 and over 1. Still the same line, so we can use that just as x. So now we have it in linear format. It is shaded down. It's a solid line. So it's less than or equal to. So, now, our next one. We're going to look at this line. 1, 2, 3, 4. So it's positive 4. And looks like our slope is negative. Down 1 over 1 is where it's crossing the next point. So negative x. So, 4 and then negative x. And our y shaded down less than dashed line. Okay, so now we are looking for a point that's shaded in both areas. So we see it shaded down this way, we see that it's shaded down this way. So I'm going to pick x of 1 and y of 1. So my order pair I'm going to use is 1 and 1. So I already have these written. I'm going to draw a line underneath this, and I'm going to replace 1 and 1. So y is 1, x is 1. I'm going to solve. 1 plus 2 is 3. Bring down the 1. 1 is less than or equal to 3. Yes, that one checks out. Next one. Y is 1, x is 1. Cannot get rid of that negative. That negative has to stay there. Okay? So, from here, this is negative 1 plus 4. We're going to bring down 3. 1. 1 is less than 3. 1, 1 is a system of solution. Okay. Next one, same thing. You're going to have problems where you have just the graph. You need to write it in linear format. So let's deal with the purple line first. We can see that the y-intercept is 1. And it looks like the rise and run is up to and over 1. So I'm going to write 1 plus 2x, and then y, solid line, less than or equal to, shaded down. So that's the first line. Second line, 1, 2, 3, y-intercept of 3, rise and run, up 3 over 1. I can check it by going backwards, down 3 over 1. That looks good. So I'm 3x plus 3. So 3 is my b plus, I'm going up 3 over 1. Okay, so now what I'm looking for after this equation is I'm looking for a solution, and understand that solution can be any ordered pair within the overlapped shaded areas of the two linear equations. So looking at this, we have a very fine point in between this orange and this purple that comes together. So I'm going to choose a number that falls within here. I could have went clear up here, but I'm going to choose something that's easy. So 4 and negative 4. Or excuse me, negative 4 and negative 4. So negative 4 on the y, negative 4 on the x. I'm going to use this ordered pair. I already have my equations written out because they were graphed. I was able to write them out. And I'm going to go replace y with negative 4 and x with negative 4. So my y is negative 4. My x is negative 4 inside parentheses. I'm going to go ahead and solve. 2 times negative 4, negative 8 plus 1, negative 8 plus 1, negative 7. Bring down the 4. Read this to yourself. Negative 4 is less than or equal to negative 7. Yes, negative 4 is a greater number than negative 7. Would you rather owe $4 or would you rather owe $7? Okay, next one, y, negative 4, 3x. So the negative 4 inside parentheses, replacing the x, substituting like what you have today, plus 3. So we're going to solve. 3 times negative 4, negative 12. Bring down the 3. Bring down the negative 4. Negative 12 plus 3 is negative 9. Bring down the negative 4. Then read this to yourself. The negative 4 is greater than negative 9. Now, sometimes our brain plays tricks on us. Ask yourself, would you rather owe 9 or owe 4? That's how you can tell. Owing $9 is greater than owing $4. Okay, a couple more examples and we're done. So, two linear equations, both in slope form. Y is less than or equal to 2x minus 3, and the y is greater than 2x plus 2. So we're going to go graph these out. So we're going to start at negative 3. We're going to go up to and over 1. This is going to be a dashed line, and it's going to be less than shaded down. Next line, 2x, or excuse me, 2. We're going to go up to over 1. It's a dashed line. It's greater than shaded up. Now, guess what happens in here? These don't overlap at all. And they don't overlap, and we can see it actually in the linear equations because we can see that the slope is the same and they have different y's. So we know that these lines are parallel. So there is no solution that they overlap. It's going on for infinity because infinitely zero solutions. They're never going to connect because the slopes are the same. Okay? It's just going to go on forever. They're never going to touch. There's not a solution to solve this problem. Okay, so we don't need to put an order pair in. We're basically done with the problem because nothing overlaps in here. So there is no solution that's going to work. Okay, next one. Both of these are in slope form. Y is greater than x minus 3, and the y is less than or equal to x plus 1. But look what happens here. These slopes are also the same. X and x, different b's. So in graphing this out, we're going to 1. We're up 1 over 1. This line is solid. It is less than, shaded down. Negative 3. Negative 3 on our b. Up 1 over 1. It is greater than. There is no equal to. Dashed line shaded up. So where these are overlapping between the orange and the purple are right here in the middle. So an easy problem, an easy solution or order pair to pick in this case is 0, 0. So we're going to use 0, 0. We're going to write the equations side by side and we're going to plug it in. Y for 0, y for x. Go ahead and solve. 0 doesn't do anything, doesn't matter. We bring down the negative 3. We ask ourselves, 0 is greater than negative 3. Yes, we'd rather owe nothing versus owing $3. Same scenario on the next equation. Our x is 0, our y is 0. 1, bring down the 1 because 0 is irrelevant. 0 is less than or equal to 1. Is 0 less than 1? Yes. 0 is less than 1. So our solution that we plugged in here, 0, 0, is a solution system. We can see that it's shaded in the overlapping area. We plugged it into the inequalities and solved for it. So we're good. Okay, last one. Both in linear format. Oh, this is interesting. Look at this. These slopes are exactly the same and they're negative. Okay, so, however, the symbols are the same. So, we're going to graph these out. We're going to go to negative 2 on the graph and we're going to go down 3 and over 1. Remember on inequalities, not that it would have mattered in this case because it wasn't a negative fraction, but you never go to the left for any reason. It's always to the right. So, we're at negative 2. We're down 3 over 1. This line is solid. It is less than or equal to shaded down. Okay. I will tell you, if you notice, you don't see me shading this. You see me using arrows. Sometimes I think that's easier, and the reason why I think it's easier is it's easier to see the ordered pair. It is clear what direction. There is no mistaking that this is less than, that it's heading downwards versus upwards. Okay. So next one. 0, 1, 2, 3, 4. It's at 4. We're down 3, we're over 1 is what our slope is. Also a solid line, also less than or equal to shaded down. So what that means is all within here, these first lines, everything on this side before we hit the orange side are not overlapping. Anything in that section would not be a solution. So as far as an ordered pair, I'm going to choose negative 1 for my y and 2 for my x. So negative 2x, negative 1. I could have went over closer. I like to be 1 or 2 over, or sometimes just to make the problem easier. Once again, it's any solution in the ordered pair will check out, so we're trying to pick something that is easy. So once again, we're going to take both our equations, write them side by side. We're going to plug in negative 2 for our x and negative 1 for our y. So our y becomes negative 1, and our x inside parentheses negative 2, bring down to negative 3, bring down to negative 2. So we're going to solve here. Parentheses, negative 2 times, negative 3 times negative 2, positive 6, bring down to negative 2. Bring down the negative 1. 6 minus 2, 4. Then we ask ourselves, is negative 4 less than or equal to 4? Well, yeah, it's pointed this direction. It's negative 1. 4 is greater. Same thing over here. Y, negative 1. Bring down the negative 3. The x is going to be negative 2 inside parentheses. Bring down the plus 4. Then we're going to solve. Negative 3 times negative 2, positive 6. Bring down the 4. 6 plus 4 is 10. Bring down the negative 1. Is negative 1 less than or equal to 10? Well, yes. 10 is greater than negative 1. Okay, so we know that the solution that we picked, negative 2, negative 1, within these two linear equations, as far as the way those inequalities are and how they're overlapping, the negative 2, 1 is a solution system. Do not forget this step. This is going to be the last step that you have when it comes to the test. Okay, let's talk about the do now. You have an ordered pair. You have two linear equations, okay? You're going to write these side by side. You're going to enter in the ordered pair, and you're going to see whether it's true. Then you're going to go graph these out. You're going to shade them properly or whatnot. You're going to plot the ordered pair. Remember that you plot that ordered pair large enough. You can either do this on your paper or you do it on graphing paper. It's up to you. Just make sure that I clearly see everything labeled and that I can also see the shaded area. I do know some of you like to really shade that in there. Start to be careful about that because now you're looking to overlap. I would highly suggest you start doing arrows and or if you have a graph and you are shading, that you shade in certain directions. Let me give you an example. Let's say this one is down, so I'm going to shade this one down, okay? And let's say our other line was up, okay? So it was going and it was up, okay? It's hard to tell what's going on here. So if you shade this one like this, then it's easier to see the overlap. So let me show this to you again. However, I personally think doing arrows is best. There really is no confusion here. So if we're ordered pair, okay, and I have a line that is like this, and it's less than, so it's being shaded down. And then I have my next line, and let's say it's shaded up. So I can see that these are going different directions. I can focus on the fact that my overlapping area is right here within the graph, okay? Once again, I personally think it's easier to use arrows. Okay, so once again, please do me a favor. I don't want to have to come back to a room that I have to pick up. Please follow directives and stuff. I want to come back in and be super proud that binders are where they're supposed to be. The books are underneath the desk that you guys, I get a glowing report that you did amazing work and we're awesome, like I know that you can be. Once again, you've got these 5 questions. You want to get these done first. Get the notes done, get the vocabulary done, so we can practice this again tomorrow and then get ready for the test on Thursday. When I say tomorrow, I mean Wednesday, which, believe it or not, it's still Friday right now. It's almost 6 o'clock, but I want to make sure that you guys have direction of what needs to happen and this sort of thing. So, like I said, nothing new. What I want done, I want your notes done. I want your vocabulary done. You're watching the lecture. You're getting the do now done today. Do not worry about the worksheet until tomorrow. Now, if you do get this all done, then please, yeah, go ahead and start to work on the worksheet. I will see you tomorrow, and like I said, I hope that I get a glowing report. Have a good day. Put the work in.